Hi, I'm Cosimo. It took some time, but finally there is a solution to effectively and accurately simulate the interaction of millimeter wave devices with the human body. The ITIS Foundation supported ZMT and integrated a new method in Sim4Life version 7. The problem is that the reflections and absorption of human body can only be approximated by very thin layers, according to a recent study of the ITIS Foundation with 37 volunteers. The layers are as thin as 60 micrometer, which must be resolved by a sufficient number of voxels to accurately simulate the matching effects. In other words, the computational resources needed for this type of simulations would explode and are unmanageable even with the largest high-performance computing clusters. Recently, Speag developed and released physical hand and whole body phantoms for CTIA and other organizations that simulate the characteristics well above 100 GHz. These are already used by more than 40 labs to assess the performance of 5G frequency range 2 or other millimeter wave transmitters. Many R&D departments of companies and universities have approached us with requests to provide simulation tools to enable computational R&D evaluations above 6 GHz. We have now a very effective method, the first solution on the market to simulate these phantoms. The new method is available in the full version of Sim4Life version 7 or its electromagnetic tool SEMCAD version 20. For this video, we have created a generic smartphone model with this phased array antenna operating at 28 GHz. And as an example, we want to determine the over-the-air parameters when we hold it in our hands. First, the user drags and drops CTIA's millimeter wave hand, in this case it is the right wide hand, which already contains the appropriate model parameters valid from 3 GHz to 110 GHz. Next, the user positions the phone in this hand according to CTIA requirements. Now the configuration can be voxelized using the default settings or using a mesh that had been optimized for this particular phone. For this phone, the mesher works perfectly. Now the mesher will automatically ensure the appropriate discretization of the millimeter wave phantom. After 30 minutes, the simulation results can be analyzed. Usually, these type of simulations would have taken almost a day. Here the results are available after 30 minutes running on a single GPU card. The new numerical method developed for simulations of human bodies has been successfully verified on a number of analytical and numerical benchmark cases, and the documentation is available for Sim4Life customers. We plan to extend this method to all our anatomical phantoms. Once more, it's been demonstrated that Sim4Life and its EM tool SEMCAD are the only tool for accurate simulations of complex devices mounted to the body. Thank you for watching this video.